talk today about practice and knowledge. And because I'm an academic, already I can find lots to talk about. Because these two things are commonly presented as a pair and as though they are in some way not just different, but maybe even opposite to one another. And of course this isn't true. Because the opposite of knowledge is something like ignorance, or maybe innocence. And I don't know what the opposite of practice is. So this is a false dichotomy. So already, when you come to the university, you get people like me talking about things like this, and it's wrong. So we'll start there. My objective is going to be to stop this division, and particularly to question whether this one is better than this one. Because that's the implication, usually, when these things are talked about. But before I go too far, I want to just do some practical things. I want to do some practice. Imagine I'm a little child, and I've got one of these. What am I going to do? I can do all sorts of things. I can try out with this ball. And basically I'm experimenting. I'm practicing in order to find out what this thing does, what it's like, whether it's interesting, what it smells like. Probably if I was a little child I'd lick it, but I'm not going to do that. So I can do some simple experimentation with my hands, probably. Okay, now imagine I'm a scientist and I'm going to do some practical things with this object. What kind of thing am I going to do? Well, I think I'm going to measure it. I'm going to conduct some kind of rule-bound activity, maybe measure how high it bounces. Why am I going to do things like that? Because I have not just an experience of playing with this thing, but I have a model, a theory in my mind of what this is and what it does. And I'm interested, perhaps, in verifying those theories, or perhaps in expanding those theories. But basically, I'm not very interested in licking it, but I am interested, perhaps, in writing some mathematics about it. Okay. Now the third thing. Maybe this will disappear from the camera. Can you just come up here for a moment? It won't hurt. One of you, I don't mind. Come here. It won't hurt. What's that? You ready? So, what we did there was something different. Apart from my initial reassurance that this was not going to be dangerous, I didn't say what we were going to do. I looked at you in a certain way, and I held the ball in a certain way, and you understood I was about to throw it, and that you were supposed to catch it. And then I didn't tell you what to do, but you threw it back. And then we did it again. Okay. Then I looked at Gravada. And apparently we were going to do the same thing. And I did something different. That was a very complex thing that we just did. But basically, instead of doing an empirical practice, like the child does, or a theoretical or hypothesis-building practice, like the scientist, we did a social practice. We played a game. We invented a game between us. And then, even after that unspoken exchange, there were enough rules that Gabi didn't know how to play the game anymore. And when it went wrong, we all laughed, which was another social activity. We thought it was funny, not too embarrassing, hopefully. So we had three kinds of practice. Three hands. Empirical. We had, well, we could call it, let's call it hypothetical. And we had social. And maybe, I'm not too sure about this, I haven't tried it out, but maybe we have things, concepts, in each of those boxes. Maybe all of them, maybe not all of them, I'm not quite sure. So let's look at some of these things. This one here has got a name. And it's called realism. This is the concept of knowledge that there is a real world out there. It's got things in it, like this, and we can interact with them, and through interacting with them, we can find out about them. So this is, empirical science is based on this. But the part of science that's based on this is the part that gathers data. So we conduct experiments in order to say, when I dropped it on the floor, it bounced 80% of the time, 20% of the time, it rolled away out of the door. It's the underlying data that's important, our connection with this. And if we have an idea, maybe we haven't actually experimented with this one before, so we have the idea that all balls are very bouncy. Now it so happens that this one is not. So we modify our idea of what these things are like. They're not all bouncy. Maybe all the ones that are constructed like this are not at all bouncy. That's one of the things that makes them different. So that's the idea of empirical science. And the important thing here is that we keep testing our knowledge against things we can do, usually kinds of scientific experiment. So I think a good example that's connected with balls was Galileo. Galileo conducted an experiment that you probably know about, where he constructed two balls of the same size. One of them was solid and one of them was hollow. So one of them was much heavier than the other, but on the outside they looked the same. And the general assumption at the time was that if you dropped these two balls, the heavier one would arrive on the ground first, so it would accelerate faster. So he took the two balls to the top of the Tower of Pisa, and he dropped them at the same time, and surprisingly, they both arrived on the ground at the same time. And so the idea of how balls travel, how they fall, had to be modified in the light of a practice. Now, of course, Galileo made these balls in this particular way because he had an idea about them, that actually how fast they fell to the ground was independent of how heavy they were. But ignoring that for the moment, because he did something, it changed how we thought about the external world. This is about reality, if you like. There is reality. Now there are some problems with this method, because when we conduct experiments, it's difficult for us to be confident that the results from this experiment will apply next week in a different situation with a different ball. And sometimes we encounter situations like this non-bouncy one, where things don't happen like we expect. And so there's a limit to how far we can transfer the information. And actually, at a theory of knowledge level, it is very difficult to defend that we could ever transfer any information from one case to another, from one example to another. So the problem with this rather practically located activity is that we find out one thing now in this room, and maybe next time it will all be different. So it's difficult to construct an understanding and a theory of how we can transfer information from one situation to another. The big strength of this theory is that what we claim corresponds with what goes on in the real world. So if we allow that we might be a little bit doubtful or sometimes wrong about our claims for the real world, nonetheless, because we have practiced with real things, what we say about them applies to real things. It's true, we're finding out about the real world. So this one has the benefit of correspondence. What I say corresponds to reality. Let's move on to this one. How does this one differ? Well, this one corresponds more to the scientist's view. When the scientist measures the object, measures how much it bounces, the scientist is trying to find out general principles. So the scientist is not so interested in this particular ball. The scientist is interested in some generalized one. Balls like this, balls made of this material, balls dropped from this height, rules, hypotheses about what reality is like. And the process of generating hypotheses is in part to test the ideas against a lot of different examples, a lot of different experiments, and to find which are the general rules that seem to be useful every time. And gradually what one does is to build up a theoretical, hypothetical model of what the world is like. Now, unfortunately, it's a little bit like average numbers or average size clothes. Average size clothes fit nobody. So, hypotheses about the world are general and useful, but perhaps they do not apply to any real example. So with this ball and any other number of balls will all be a little bit exceptional. And if you remember what it was like to study science at school, you do some laboratory experiments and you draw a graph and you'd have all of these results like this. And you say, aha, there, that proves that the bouncing ball behaves in a certain way. But this is cheating. Look, this line does not touch any of these points, not one. So this general rule did not apply to anything that we observed in class. And all of science is like that. All of these general rules do not actually fit anywhere. So we have to be a bit careful how we use this, and this also has a name. This is idealism, because we idealize what we are looking at. We say, ideally, a perfectly round ball made of perfectly bouncy rubber will behave in a certain way. But of course, real ones don't. Now the great strength of this one is that it has coherence. This model, this approach, we can make all our theories fit together because we have streamlined them. We have got rid of all of the difficult granularity of reality, and we have made some general rules, and the more they fit together and the simpler they are, the more we like them. Now this one is where all the trouble starts, because this one seemed so beautiful and so sexy that Plato, 2,500 years ago, just could not say no. He thought, this has got to be the underlying truth of the world, and so I will build an entire philosophy that will last 2,500 years on this idea, even though it has very little connection with reality. And we still read Plato, we still think he's a very important thinker, but some of his ideas about the fundamental nature of reality are completely local. Nobody would think those things now. So each one of these has an approach to external reality. Either thinking that it is full of real but complex experiences that are individual, or this one, that the underlying truth of reality is that there are general rules, there are patterns, we can derive some rules about it. And according to which attitude we have when we get out of bed, so the things we do will be different. The child will perhaps take this into the garden to play with. The scientist will take it into the laboratory. Both of those actions indicate the way they are thinking about this object and its potential. What about that social activity that we did? Down here, what does this tell us? Well, I think what was interesting about the social activity was that the ball was no longer really the subject. It was not really the most important part. The important part was the interaction. This mediated an interaction. Ultimately, what you and I did, we played a game. We played a game using the ball, but the ball wasn't really the main thing. And at the end of the day, I guess maybe we would go home and say, I had a nice game, a nice day because I played a game and I enjoyed it. So it's the social part of what went on, like breaking the rules, and we all loved. None of that was the ball. The Paul really didn't make us laugh. Maybe I did, or the situation did, but the ball didn't. So in this one, the whole focus of our interest is not really on this anymore. So here, this one, we were probably thinking about the ball. Certainly in the beginning here, we were very much thinking about the ball. Here, we were thinking a bit less about the ball and a bit more about general patterns to do with the behaviour of objects. And now on this one, I think the ball has more or less disappeared. Because now we are interested, the knowledge that we gain from social activities is about one another, not so much about our individual psychology, but about how we live together, how we live socially, and what can be generated when we start to interact one person with the other. This is our general state. This is us, and we get out of bed in the morning. We then do things. And what we do reveals to anyone else our model or our worldview. So I said to you, when the scientist goes into the laboratory, instead of going to the football pitch with the ball, it reveals a certain interest, a certain view about perhaps who the scientist is, what his interest is in the ball, how he is going to investigate it, how he is going to get knowledge. But then we could also think about this the other way around. We could say that we have a certain worldview. If you're studying architecture, you're probably all sitting there thinking, what the hell has this got to do with architecture? When is he going to mention buildings, space, something like that? So, what you think is an adequate lecture, what you expect to go on in this room, or the kind of conversations you expect to have in the university, are all to do with who you think you are, how you've been trained, the geographical location that we find ourselves in. So we might be coming at it really from this point of view, that rather than this, which is us, here we've got our social context, and we're expecting certain practices. We're expecting to draw rather than write. We're expecting to talk in a certain way rather than another way, the elevator conversation or the conversation that you have with the rector. And perhaps it's this one that leads to architecture. Because you're actually trying to make your practices result in architecture, look like architecture, or add to your credibility as an architect. But that's a social practice now.
As we have designers in the audience, would you say that architecture and design is more or less the same?
Yeah, I think we can put any of our professional identities in here, because this one suggested in the beginning that perhaps if we are children, then we're inclined to experiment and enjoy the phenomenological aspects of experience. And if we are highly educated, like the scientist, we perhaps have a deeper understanding. I'm using a lot of words that are full of value here. The scientist has a deeper understanding. If you remember, right at the beginning I said maybe the opposite of practice and knowledge. The opposite of knowledge is ignorance or innocence. Ignorance sounds like something bad. Innocence sounds like something charming. All of these words have got value attached to them. So we could say that the child innocently, naively plays with the ball. The scientist, as an educated person, understands more about the real world and can explain how things happen and predict behaviour. But in the social environment, we've got a similar set of activities. As university students, you perhaps would be disappointed if I set up an activity for you in which apparently you only play with the ball. You'd want to say, well, what do we do with the ball? What do we do now? What are we supposed to conclude from this activity? Because you are supposed to be increasing your understanding. And then in the professional world, if we're in the design office or in the art studio, or we're on the psychologist's couch, there are certain behaviours that we expect. If we pay our psychoanalyst hundreds of reais per hour, we expect a certain kind of conversation. We don't expect to only play with the ball and not talk about it afterwards. So yeah, I think this is how you get out of bed in the morning. Depends partly how old you are. It depends how you have been enculturated, so how you have been educated, but also how society has told you who you are. And also, of course, you have personal ambitions as well. If you are a design student, we could say you are trying to be a designer. One of the ways of looking as though you're a designer is, first of all, to go and do a design course, and perhaps in the end to have a design diploma, and to have an exhibition of your work, and a website. These are all things that add to your credibility as a designer. You don't have to do any of these things, but society kind of expects you to. So you start from different points of view here, and I'm saying that influences what you do, how you interact with the world, because you have got a certain view already of what constitutes knowledge or what interests you. There are things that you could find out about, but you're not interested. And working the other way around, because you already have these terrible prejudices, there are certain things that you allow yourself to do and certain things that you don't. You know, as the lecturer, I'm not supposed to do this too much. You know? So there are certain behaviours that are expected. You messed up the camera. With a view to where you are going, what you're trying to use this for. That you are trying to be an architect. So some of what I am saying about this social practice is that we try hard. We try to be architects, designers, shop assistants, whatever it's going to be. And we indicate that through our practices. There are some things we haven't said about the ball. I mean, we've said a lot about the ball, I admit it's a bit of a start today, but there are some things we haven't said about the ball. If I were to, I'm not sure which one of these I'm going to be now, you can tell me. If I'm going to be an anthropologist about this thing here, I might want to watch how people use it and observe, and probably as an anthropologist, I'm going to be especially interested in seeing how the original makers played with this thing, because I can see this is made from, let's call it, primitive material. It looks as though perhaps It's artisanal. It was made maybe in the favelas or actually in Thailand. So this ball is a type of ball used in Thailand, made out of local materials. So immediately the anthropologist is very interested in this, made from unusual materials, and perhaps it's used for a certain kind of game. I think it is. They use it for all sorts of things, but I think there is a special game associated with this kind of ball. Okay, so there's an anthropology. Now we're beginning to hear the history of the ball. This ball has a history. It was brought from Thailand to Brazil by my brother-in-law, and to my son to play with, because he liked it, because he was a little child and he played with it on the floor, just like I showed you in the beginning. So the ball has a history. We could talk about that. What else can we talk about? Now, I can use it in some novel ways. Supposing I'm rather tired, I could perhaps prop my book up on it. I could use it for some purpose other than ball-like activities. I could use it as a container. It's got little holes so I could put things in it. I could probably make a musical instrument out of it and play music. All sorts of things that I could do with this that are not to do with it being a ball. So all the way through all this conversation, we made an assumption that this is a ball. Maybe it's not. Perhaps I can't remember what it's called. No, one of them. And another thing we've been doing the whole afternoon, God, it seems like the whole afternoon, doesn't it? We've been having a lecture about this. I've been standing here, you've been sitting there, you've been quiet, I've been talking, you've been listening, you've been pretending to make notes. I'm not just pretending to make notes. So there's a whole academic thing that we've been doing with this that no child would dream of doing. How boring is that, to spend an hour talking about this instead of playing football with it? So this all depends who we think we are and what we're trying to do, and it's to do with worldview and this word that I said I didn't really like much. Knowledge. So why don't I like this one very much? Well, first of all, I don't like the way that it is separated from practices. Like I said at the beginning, these two things are not separated, they're not opposites, they're not even connected like that. I don't think they're connected at all. So we start off with a very false view that one leads to the other. Perhaps this one leading to this one. Well, if they are connected, this one comes first, and it leads to this one. But there's not really a strong connection, I don't think. Because these are so varied. And what's more important is the worldview. I think what happens is that. So now they're not joined together anymore. I'm just saying a last thing perhaps about why is this important? Why should we be interested in this? In the university, I think the principal objective is this one. Partly teaching knowledge to students, but also creating knowledge or finding new knowledge through research. So this is what the university, this is what the business of the university is. Now in fields like architecture and design and visual media and so on, this is very important. We're thinking that after university we're going to want to be a professional practitioner. So we need some of this as well as some of this, and that's where it's tempting to link the two things together as though one causes the other. Now I think that's a slightly exaggerated view of being an architect or being a designer. Because whatever you want to do after university, you're going to need some of that. I'm using some of that now. I'm standing here, I'm making a presentation, I'm trying to remember not to walk out of the frame of the camera, things like that. So there are professional competencies associated with any activity, and prior knowledge, prior enculturation, my worldview is going to inform everything I do. So architecture, design is not different from every other kind of activity. Everything that's involved in the real world involves practices. But behind that we have a lot of prejudice and assumption that comes from what we think is knowledge about these activities. I think at that point we'll stop and talk about it.
Thank you very much, Michael.